Sorry about that. A little bit of technical difficulties. So for those of you who may be watching us out on Facebook, bear with us today. This is the first time we've actually streamed out on Facebook. So if there are any technical difficulties, I just wanted to let you know that we will post the video a little bit later as well, the recording, so you won't miss a thing. So just so you know. My name is Amira Fahum, and I am the Education and Programs Leader at Compass Senior Living. We are based out of Eugene, Oregon, and I'm sorry, I'm getting a message that we're having trouble playing the video on Facebook, so I'm going to try this one more time here. Okay. Hang on just a second. Sorry about that, guys. We have a little bit of technical difficulties here, but we will get it fixed here in just a second. And but I don't really want to hold things up, so give me just a second. And I may, Ansley, just have you go ahead and start here in just a minute. Because I think what happened was my settings got taken out of my live streaming video here really quick. So, all right. All right, Ansley, I'm going to go ahead and have you go ahead and start. We are recording the session, and so for those of you on Zoom, we'll go ahead and get started, and then I'll get this up streaming as we go along. So without further ado, I actually would like to introduce Mrs. Ansley Browns. She's worked at NASA's Johnson Space Center in Houston, Texas since 2001, and she is originally from Tallahassee, Florida, graduated from Birmingham Southern College with a degree in math. And she currently serves as a payload facility integrator on the International Space Station Program Office, where she coordinates with multiple NASA teams across the US to ensure that the science facilities on the International Space Station are working well. So I'm going to let you take it away, Ansley, and we will get started. Go ahead.
Great. Thanks so much, Amira. I'm so excited to be here with you guys today. And I'm going to tell you a little bit about what it's like to live on the International Space Station. I have not been there myself. I'm not an astronaut, but I've worked with some, and I'll give you a little bit of background, and I'm happy to take your questions through Amira at the end. So let's talk a little bit about the space station. This is a picture of what it looks like, and this picture was actually taken just a few days ago when the most recent visiting vehicle came to the space station to bring up some new cargo and supplies and science experiments. You can see it's pretty big. To give you a reference, it's this entire complex with all of the solar arrays is the size of a football field. It's the third brightest object in the night sky. It flies over, and you can see it from our hometown. I'm going to tell you guys a little bit more about how to do that later, but this gives you a feel for what it looks like. I have a slightly better picture that's a little bit older, but gives you the same feel. This is basically still what the space station looks like. So again, the size of a football field, those big square looking things on the ends are solar arrays, and they collect the sun's energy to generate power for the space station. So it's completely solar powered, flying around the Earth. The astronauts live inside several different modules, and those are the silver round cylindrical items you see kind of in the middle. Let's see if I move my mouse. It's the interior volume of the space station is about the size of a 5-bedroom house. So it's pretty good sized. We've built it over the years, and I'll tell you a little bit more about that. But in this picture, you can see basically all of the main components. You've got the solar arrays, these modules where the astronauts live and work. Over here on the end, this is the exposed facility where we can put experiments outside the space station to be exposed to the vacuum of space, as well as to be able to look down at the Earth. And then several different vehicles kind of hanging off the end that come up, bringing both people and cargo. And I'll talk to you guys about that. So this picture was taken in May of 2011 towards the end of the space shuttle program, which built the space station. And this video is going to show you, give you kind of a reference. When I talk about it going around the world, what does that really look like? So let's see if we can get the video to take. Well, Amir, I guess the internet's not cooperating with either of us today. The space station goes around the Earth. It's about 250 miles above the Earth. There we go. Traveling at 17,500 miles an hour. So it's going really fast. And this video that's running now shows you what it looks like from way far away. How the space station is that green object going around, is rotating underneath. So one orbit around the Earth takes about 90 minutes. That means that the astronauts see one sunrise and one sunset every orbit. So that's about 15 or 16 sunrises and sunsets every day. So they can't tell time. They don't tell their day by the sunrise and the sunset the way we do on the Earth. Instead, they tell time. They use one reference point, and they use Greenwich Mean Time. So basically, the astronauts are living on the same schedule as folks living in London, which means they get up really early.
Hey guys, it looks like Ansley's having a little bit of trouble here, so give us just a second and we'll bring her back. Sorry about that.
Sorry, Amira, my internet's being a little finicky this afternoon.
That's why I said, that's why I put the disclaimer out earlier, everybody. It's 2020, so bear with us on any of the technical issues. Go ahead, Ansley.
Thank you, apologies. So a little bit of background about the space station, not too much history, but a little bit. The space station assembly actually began 22 years ago. It's amazing to believe. With 2 launches. On the left on this slide, you'll see a picture of a rocket launching out of Kazakhstan with the Zarya module, the very first module of the space station built in Russia. And that picture on orbit is here on the lower left. And then a couple weeks later, the space shuttle launched out of Kennedy Space Center in Florida with the Unity node and rendezvoused and docked with the Zarya module. And this is the first mission to assemble the International Space Station. And comparing this picture to the one that we looked at a little while ago, you can see how small it was and how big it's grown. So over the next many years, about 13 or 14 years, we were in the assembly time frame. We were building up the different components. And then we got our first crew. So our first crew arrived a couple of years later. This picture on the right is what the space station looked like when that crew arrived. So we got one more module. And then we started living and working in space. These 3 astronauts here were the very first crew of the space station, launching in November of 2000. So it's a really exciting time for us at NASA and with the International Space Station program, because we're celebrating 20 years of continuous human presence in space. The US astronaut Bill Shepard in the middle of this picture was the first commander of the space station, along with his 2 Russian crewmates. They lived on the space station for a couple of months and again started that continuous human presence. So a nugget I like to point out, perhaps something y'all can tell your kids or your grandkids, if you've got children or grandchildren that are 20 years old or younger, they've never been alive when the entire human population has been on planet Earth. We've always had at least 2 people living and working in orbit in space on the International Space Station. And it's just really amazing to me to think that it's been 20 years. So again, the same picture showing what it looked like at assembly complete. Continuous human presence all the way back, going back to November of 2000. So I'm going to transition now to tell you a little bit more about the coordination that goes on. The first slide is international. We work with countries around the world. And in this picture showing the map of the Earth, you can see references to where all the different places are on the Earth where we've got people coordinating, working to run the space station. We've got mission control centers, of course, here in Houston, what Houston is known for with NASA, as well as all around the world. And we all work together to make sure that the astronauts are safe and healthy on the International Space Station. This map shows you a picture of where all of the astronauts who have ever been to the space station have come from. And they've come from all over the world. Again, someone at least every continent represented, many countries, and we continue to fly people today. So a little bit about the folks that are actually living on the space station right now. We have 7 astronauts on the International Space Station, and it's the most that we've ever had living for a long duration mission, a long period of time. And they're members of the Expedition 64 mission. Expedition is just the word we use to describe the missions on the space station. So it's the 64th crew, going again all the way back to that first crew that launched in November of 2000. So it's a multinational crew. We've got several US astronauts, a couple of Russian cosmonauts, and a Japanese astronaut. So this picture on the right is a picture that was taken just after the 4 people in red arrived at the International Space Station. We've got 3 American astronauts here, along with our Japanese astronaut, Soichi Noguchi. And it's an exciting time to have 7 people on this space station. I'll explain a little bit more about how they got there shortly. But these guys are all living and working together, doing research. And I'll tell you a little bit about what it's like for them on a regular day. But some of their fun pictures, they arrived, this most recent crew arrived just before Thanksgiving. So in the lower pictures, you can see a picture of their Thanksgiving Day celebration, just like many of us here in the US had, all sitting around the table. Now I'll say sitting, they're not really sitting, they're actually floating. Even though it looks like maybe a couple people on the right are standing, if you look at the bottom, you can see this is astronaut Kate Rubins. It's her 2nd mission to the space station. She's got her toes underneath a little bar here so that she can stay in one place. And on the right, her hair is floating. So they are indeed floating on the International Space Station around their dining table. So sleeping. Right now, I took a look at the astronauts' timeline just before I logged on to see what they were doing, and I realized, of course, it's just about their bedtime. So each astronaut has their own place to sleep on the space station, and it's kind of like camping. They sleep in sleeping bags that are attached to the wall so they don't float around. These pictures demonstrate both on the right, you can see Koichi Wakata, a different Japanese astronaut who flew several years ago, demonstrating his sleep station. So they each have a little room, that's their private area, their private crew quarters, and their sleeping bag is attached to the wall there. Along with, you can see a personal laptop so they can check email, read books if they have a book on their computer, perhaps watch a movie, and also talk to their friends and family. So I like to say that while this kind of looks like a little camping area, sleeping on the space station is not like summer camp. It's not where we turn out the lights and everyone has to be quiet. They have about an 8.5 hour sleep period, and they can use that time as they want. Again, email, talking to folks on the ground, or sleeping. Most astronauts will say they sleep on the order of 6 to 7 hours a night. And they sleep, like you see here, the sleeping bag has a little bit of personalization. If some astronauts like to sleep with their arms out like that, others like to keep their arms inside their sleeping bag. Some of them like to have the sensation of a pillow because again, they're just floating, and you can see in this picture, Koichi's head's leaning forward a little bit, and that's just the natural position that the body assumes when it doesn't have gravity exposed. So sometimes astronauts like to have that sensation of a pillow, and then they might use a piece of cloth with Velcro to Velcro their head back to the back of their sleeping bag. I mentioned being able to call family from space. One cool thing that's developed over the past several years, 20 years again, that we've had people living on space station, our technology has changed and advanced a lot. So now the astronauts can actually call home. There's a phone on the space station, basically in the computer system, where they can dial any number they want to and connect with friends and family on the ground. Sometimes they're really nice and they'll call people that work at NASA to wish them a happy birthday on their birthday, or call their friends and family. They have some regular setup their immediate family has some special equipment where they can do a little more regular video chat, but that's part of the experience of living and working in space. The picture on the left is from a little bit longer ago, but it shows you the different crew compartments, how each astronaut has their own, and they all kind of face towards the middle. Also, this picture was taken, I thought it was appropriate for the time during the holiday season with a little Christmas tree up there and Santa Claus hat. The astronauts like to have fun too. Speaking of fun, every astronaut that I've ever talked to about going to space will tell you that eating in space is lots of fun, no matter your age. On the upper left picture, there's a picture of Chris Hadfield, who is a Canadian astronaut. He was a commander several years ago. He's showing you some of the food, example of the food on space station. This is actually creamed spinach. In one hand, he has the creamed spinach before it's been rehydrated, and on the other hand, I believe it's his right hand on our left, is after it's been hydrated. So one of the ways the astronauts cook is they'll get dehydrated food. You can see here, it's much smaller, it's compact, which makes it easier to get to the space station. And then there's a special device where the astronauts can add water and mix it around and rehydrate it and heat it up and eat it just like we would. So this is a spinach on the space station. But other food, of course, is more fun. The astronauts have said they like to use tortillas because they don't flake and fleck like bread does. So on the left, one night, some of the astronauts on this particular crew made pizzas. And again, no hands required in space. In the middle, there's a picture of Peggy Whitson with a hamburger she made during her flight. And you can see all the yummy treats just like we would have here on the ground, except it's on a tortilla and it's floating. I couldn't find a good picture of M&Ms, but candies on space station are always fun. And this picture at the top with Scott Kelly showing you how the candies are just floating there. And of course, in their free time, they like to have fun with that. One of the things the astronauts will tell you they love the most is when a cargo spaceship comes to the space station and brings fresh fruit and vegetables, because they don't get a lot of fresh fruit and vegetables. Again, most of their food has to last for a long time. So it's shelf stable or dehydrated food. But this picture, Kjell Lindgren, who flew several years ago, was very excited to open up a bag of fresh oranges when one of the visiting vehicles came up. So food, fun at any age in space. On the exercise front, the astronauts actually exercise 2 hours every single day to maintain healthy muscles and bones. One of the reasons that we're flying the International Space Station and that we fly astronauts for so long in space is to learn how the human body adapts to being in microgravity. Right now, our astronauts fly on the order of 3 to 6 months, sometimes up to 9 months at a time. And so they exercise every single day to again, maintain healthy bones and muscles. We have a couple different ways that they can exercise that I've got pictures of here. In the upper right is Sunny Williams. This is on the old treadmill. So there's a treadmill, a stationary bicycle, and then a special weight resistive exercise device that I'll talk about. In the upper right, in I believe it was 2007 or 2008, Sunny Williams flew to the space station. And before she launched, she had qualified to run the Boston Marathon. And it turned out she was going to be in space on the space station when the marathon happened. Well, she still wanted to run, so she got her number. And it turned out that the time of the actual marathon on the ground was during some off-duty time for the astronauts. So Sunny ran the Boston Marathon, 26.2 miles on the space station treadmill. And you can see here her number pasted there on the front of the treadmill. Just goes to show that astronauts like to have fun and maintain as much of that normal experience as they can. But she ran the marathon during the same time as all the other runners. On the bottom, below that picture, is a picture of ESA astronaut Samantha Cristoforetti. She flew a couple of years ago, and this is a picture of her demonstrating running on the treadmill on this space station. You can see the way that she runs on the treadmill is through harnesses. So they put on a belt, and there's some straps you can see on her shoulders that are attached to some bungee cords that attach them to the treadmill. So there is a little handrail right here, but it's not really used to hold on. It's mainly these bungees. So they'll put on their tennis shoes and they can run. Can't really see it. There's a computer right here. So just like us if we might go to the gym or the exercise room and turn on a movie or a TV show while we walk on the treadmill. The astronauts can do the exact same thing. So they'll do typically an hour or so of cardio every day, whether it's on this treadmill or over here on the stationary bicycle. It kind of works the same way with the bicycle. Don't have to have any handlebars or a seat, but we do have to make sure the astronauts stay attached to it. So they put on a belt that connects them kind of to the wall to this device, and then strap it in the pedals, and they can go for a ride. At the bottom, on the left, you'll see Kjell Lindgren again. He's demonstrating one of our exercise devices that's called the Advanced Resistive Exercise Device, ARED. We like our acronyms here at NASA. And this is an opportunity for the astronauts to do different kind of weightlifting exercises. Of course, they're not actually using weights. Even in space, I could lift 200-pound dumbbell, but not here on the ground. So in space, we use resistance. If you think about taking a rubber band and you pull the rubber band, you can feel that resistance in your arm muscles. It's a similar concept with our resistive exercise device that provides resistance so the astronauts can do squats, as you see Kjell doing here. You can do push-ups, pull-ups. I think it's something like 30 different exercises to make sure that you stay strong and healthy. And actually, I talked to one astronaut one time who said he worked out so much on the space station, he actually came back to Earth stronger than he was before, which I think is amazing when you think about going to space and there not being any gravity. So again, 2 hours every single day. Of course, their day also includes hygiene. I have a couple pictures here showing how the different astronauts have demonstrated taking care of their bodies in space. So of course, brush your teeth. The astronauts have special toothbrush or special toothpaste, excuse me, that they don't have to spit out, but they can brush their teeth like normal. The bottom, this picture is Karen Nyberg. I like to show this picture because it demonstrates washing your hair in space. And if you're interested, there's actually a video that Karen took and put on the internet. So you can search YouTube or Google for washing your hair in space. And there's this great video that Karen has, but you can see she's putting some dry shampoo, or sorry, rinseless shampoo in her hair. She's looking at a mirror. And so she puts water in her hair and then some of that shampoo, massages it all around, and then wipes it out with a towel, and that's it. In the middle, this picture is a picture of astronaut Shane Kimbrough giving himself a haircut. Obviously, we don't want flecks of hair floating all around the space station, so it's connected to a special vacuum, the trimmers here. So all the hairs go into this tube, get sucked in. Another funny story about Samantha, this picture over here, she has short hair, and she was going to keep her hair short during the mission, which meant that her crewmates had to cut her hair for her. And she asked one of her, my understanding is that she asked one of her crewmates to go with her to her hairstylist so that that crew member could see how to cut her hair correctly. And she seemed happy during the mission, so I think you did a good job. On the left, of course, one of the questions that astronauts get asked the most is how do you go to the bathroom in space? And these two pictures show you a demonstration, well, not a demonstration, show you a picture of the toilet. So this is the toilet on the International Space Station. This bottom part here for solid waste. This tube is connected to a funnel that European astronaut, British astronaut Tim Peake is demonstrating in this picture. Goes to a funnel that's used for urine, for liquid waste. And I point this out both because, you know, everyday functions that we do on the ground, everything you do here on Earth, that we have to make sure the astronauts can do in space. But there's a lot of engineering that goes into this. So there are lots of people on the ground that work on making sure the toilet works, that make sure all of the equipment works, that enables our astronauts to live healthy on the space station. And again, the reason that we're doing that, the reason that we're living so long is because we want to know what it's like to live in space for a long time, because eventually we want to go on to Mars. We want to send people to the moon, which is a shorter trip. But when we go to Mars, that's at least a 6-month trip one way. So you're looking at 6 months there, 6 months back, and probably about 6 months on the Martian surface. So we need to understand how to keep our astronauts safe and healthy for long periods of time. By flying them on the space station, we can learn more about how to keep them healthy for a long period of time when they're still relatively close.
Sorry, everybody. It looks like we just got interrupted with her again. But bear
I'm
with.
back.
Are you back? Okay, good.
So sorry. I guess everybody is anxious for the holiday, or the internet is anxious for the holidays as well. So I'll share this picture. This is the picture of the orbital outhouse team. So again, a tribute to all the engineers and people that make it possible for everything on the space station, not just the science, but keeping them healthy and safe as well. So research. So those are the previous couple of slides I've shown you have demonstrated kind of the everyday life of the astronauts. This slide gets into more of what we really want them to do, which is research and experiments on the space station. So we have many different types of research in all different areas of science, both inside the space station that the astronauts work on, as well as external science and research, where we want to expose different materials to the vacuum of space. But in these pictures, these show some of the astronauts working inside the space station doing research experiments. And this is what I'm really involved in right now in my current job. My job is to make sure that these facilities that the astronauts are using are in good working order so that when the science comes up, the astronauts are ready to go. So we've got a couple of glove boxes where the astronauts can do special experiments with different life sciences to keep things contained. This picture on the left shows one of our Russian cosmonauts working with the freezer system. So with a lot of the experiments, the scientists might have samples they want frozen and returned to the ground. So we have special freezers that can keep materials chilled at very cold temperatures. And you can see, again, one of the Russian cosmonauts working with that freezer system here. I will also say when the astronauts, going back to the food, again, food is fun in space. One thing they look forward to when visiting vehicles come up is bringing things like ice cream. And of course, ice cream's only going to last a couple of days, but they use a couple of those freezers specifically for some of their cold food too. And then here on the right, I think this is a really fun picture. It shows Scott Kelly gardening in space. So one of the things that we're working on now is doing more experiments growing things in space. Of course, long term, we would love to be able to grow food in space. And some of the research we have involves how do you optimize growing plants in space without sunlight or soil. And in this case, they were growing some plants. I think they were zinnias, I'm not sure. But he really enjoyed growing those flowers, especially because Scott Kelly is the astronaut who actually spent one whole year on the space station consecutively. He holds the record for the US astronaut with the longest consecutive time in space, almost 365 days. I think it's about 320 something. But he said later it was really great to be able to grow this thing in space because he was living inside the space station, not seeing the same beautiful nature that we are able to experience here on the ground. So speaking of amazing things, the astronauts will tell you they're pretty much consistently their most favorite thing to do on the space station is look out the window. And I pulled just a couple of pictures. There are hundreds of thousands of pictures astronauts have taken looking out of the space station. But the view they like the most is from the cupola window. And that's the window, this upper right-hand corner, astronaut Tracy Dyson is in the cupola looking out. It's a great picture to show you just how big that window is. And it's a really unique window because it's in a way that the astronauts not only can look straight down, but they can kind of look out to the side so they can really see the curvature of the Earth and get some spectacular pictures. Some other pictures here that I showed that just to show you how you can actually see, they can recognize where they are over the Earth. Night pictures, of course, are spectacular. Upper left-hand corner, that's a picture of the Nile River Delta. And it's taken at night, so you can see, it shows you kind of where humanity lives with all of the lights all around the river. And then you can see the Arabian Peninsula over here. Lower left is the Florida Peninsula. Astronauts love to take pictures of Florida because Kennedy Space Center is located right here off the coast, on the Atlantic coast. And I personally always like to see those because Tallahassee, Florida, like Amir mentioned where I'm from, is right up here. And that's one thing the astronauts like to do a lot is take pictures of their hometowns as well as other interesting places over the Earth. So taking pictures is both fun for them because they can take pictures of places they want to see, but also some of our science experiments revolve around taking pictures from space. Over time, astronauts will take the same, some researchers will ask astronauts to take pictures of the same location multiple times over years to see how the environment's changing, what impacts might be happening. And it's just a really unique view that you can't get anywhere else. This lower right picture, we always like to include here in Houston because it shows a picture. This is actually Texas at night. So right here, this is Houston on the Gulf Coast. And then this picture, the bright lights to the lower left of that are actually Dallas at the north and Fort Worth. So again, pictures from space at night are really cool when the skies are clear. So now I'll move on to tell you a little bit about how the astronauts get up to the space station. So for many years, since the space shuttle program ended, we've been launching astronauts on the Soyuz rocket. It's a Russian rocket, Russian capsule that launches out of Baikonur, Kazakhstan. And this is a picture of that launch. Fun fact, the astronauts, when they launched to the space station from Kazakhstan, they used the exact same launch pad that Yuri Gagarin used when he became the very first human to launch into space back in 1961. So lots of history at this location, and there's enough information for probably a lecture for an hour on the history of that location, but we'll keep going. So of all of that whole rocket that launches to space, the only part that actually gets into orbit is right here. And these letters here say Soyuz in Cyrillic in Russian. So this is a picture of the Soyuz capsule attached to the space station. And if you look at this picture on the left, it shows you just how tiny it is. There's enough room for 3 astronauts. So if I was there with you in person, I would say, all right, everyone look to your right, look to your left, and imagine a Volkswagen Beetle, maybe 2, and that's what it's like to fly to space on the Russian Soyuz rocket. It's very, very small, but it's a very, very sturdy vehicle that has a lot of really great history and has worked really, really well. So again, you see, this is what it's like for the astronauts to fly up. When they land, they actually land on the ground, and only that small landing piece comes back. Everything else burns up in the Earth's atmosphere when they come home. So I think this picture in the upper left is pretty cool to show you how use the parachute to slow down. And this is a completely safe picture. Nothing is exploding. This is actually a picture taken right at landing. Some retrofire rockets fire right before it hits the ground. And the photographer caught this amazing shot. So you can see a couple different landings here. They land in the snow. Typically, if it's raining, we tend to wave off a day. But once the astronauts depart from the space station, they're coming home. So you can see the snow in the wintertime. The capsule looks pretty charred after coming through the Earth's atmosphere, but they'll come out the top, and then they're resting in couches. Again, typically after being in space anywhere from 3 to 6 months, it takes a little bit of adaptation time to be able to walk around after living in microgravity for so long. So they'll lay in these couches, and then they're carried to a helicopter that takes them back to an airport that will take the American astronauts back here to Houston for their rehabilitation back into the Earth's gravity. And then our Russian cosmonauts will go back to Moscow. And if we have other international astronauts, they'll also go to their home countries for their rehabilitation and debriefs. So our other spacecraft that we're so excited about this year is the Commercial Crew Program's SpaceX Dragon capsule. So it's been since 2011, when the space shuttle program was finished, that we've had people launching to space from the US. And earlier this year in May, we flew the demo flight of the SpaceX Crew Dragon capsule that took 2 astronauts to space this summer. They flew to the space station and came home, successfully demonstrating this capability. And so then 1 month ago, actually almost to the day, I think, these 4 astronauts that you see here, Shannon Walker, Victor Glover, Mike Hopkins, and Suichi Noguchi, flew to the space station for their standard 6-month mission on the SpaceX Crew Dragon capsule. So it's only the 2nd time that people have flown in this particular spaceship. This picture on the left is from their training, but it gives you a feel for what it looks like. It's a bigger capsule than the Soyuz. You can see it can take 4 people, and they've got a little more room to move around. Not a ton, but a little bit. So this picture on the lower left shows their rocket launch. They launched when it was dark outside, so it's a spectacular view. And then this picture in the middle shows how as they approached the space station and docked. And then this lower picture demonstrates the landing. So this is the landing of the previous crew this summer. Again, these 4 astronauts are still in space, but it shows you the difference from the Soyuz, that these astronauts will land in the water. And this landing here in the water that took place in August this year, another fun historical fact, it's the first time that people had landed from space in the water since 1975, when the Apollo-Soyuz program concluded and our Apollo astronauts landed in the Pacific Ocean. So these astronauts, these 4 folks, will be on the space station until March. And then also Kate, Rubens, and her 2 Russian crewmates that launched earlier this fall, they will also come back to Earth. I think they're coming back in February. I don't remember the exact date. But again, on the order of 6 months. I did want to point out that NASA is working with another commercial partner, Boeing, who's also developing a spaceship to take people to space, a different capsule. It's called Starliner. And they've had 1 uncrewed test flight mission that did not reach the space station. So they're flying a second uncrewed test flight, hopefully in the spring of this coming year, that will dock to the space station and demonstrate its capabilities. And then 3 of the 4 astronauts seen in this picture will be going up to the space station later next year. Mike Fink here in the middle, Nicole Mann on the end, and Butch Wilmore, 3 NASA astronauts will fly to the space station on the Boeing Starliner. And Chris Ferguson here, he's a Boeing astronaut. He works for Boeing now. Another fun fact, Chris Ferguson, he goes by Fergie. He was the last space shuttle commander, and he retired from NASA after the space shuttle program ended, went to Boeing to help them with their capsule, and he actually was planning to fly on this mission, but as the schedules shifted, as schedules change, certainly we've seen that this year, it turned out the mission was slipping to overlap his daughter's wedding next summer. So he stepped back from the mission, and he will perhaps fly on another mission. But these 4 folks have been training for a long time to go to space station again on a different capsule to give us more flexibility in how we get our astronauts to space. So, like I mentioned earlier, you can see the space station from wherever you are, as long as it's clear outside and when the space station is flying over. So this picture on the right I took from my backyard back in June, and it actually was really dark outside, but I set the exposure on my phone for a couple seconds, so that's why the moon looks a little brighter. But that little dash right there, that's the space station flying over. It looks like a really bright light flying in a straight line overhead. It doesn't flash or twinkle. The light that you're seeing is not actually coming from the space station. It's actually sunlight that's reflected off those metal parts that I showed you earlier that we can see here on the ground. And if you go to this website, spotthestation.nasa.gov, data is pulled directly from Mission Control. You can type in your hometown, select that, and then clicking on the little blue icon that will show up over your town, there'll be an option to view sightings, and you'll see the list. So I pulled a couple of locations that Amir might be joining us today for: Eugene, Hayden, and Waterloo. My apologies, I had a typo there. But it looks like there's actually a really spectacular pass coming up this weekend, well, early next week, Sunday morning and Monday morning. So it's really early. I personally am not a morning person, so I like those evening passes more. But if you're up early, if the skies are clear in these locations, you can go outside, and actually the way that the orbit lines up, they'll all be coming from the southwest. So you'd look to the southwest at this particular time. I will tell you the time that's listed here is actually when the space station will come over the horizon. So usually with trees or buildings, it takes maybe a minute before you would see it. But the height is really, it's going to look like it's almost directly overhead. These degrees, it's the degrees from horizon for where it will fly over you. So in this case, these 81, 84 degrees, you'll basically be looking straight up and the space station will be flying over. Again, bright light and a straight line. So if your town is not listed here, or if you want to share it with friends and family, just give them this website. It's updated regularly, again, with information from Mission Control for when the space station will be flying overhead near dusk or dawn, so that it's lit by the sun, but it's dark here on the ground, and then we can see it. That's the end of my presentation. I'm certainly happy to take your questions. Amir, do you have any questions?
I have a couple. I'm not seeing any in the chat, but for those of you on Zoom, please enter them into the chat. And there's still time, but I do have a couple actually that came to mind as you were talking, and maybe you already answered it, but it may be worth repeating as well. What's the longest anyone's been on the International Space Station at one time?
That's a great question. So the longest is astronaut Pat Kelly. He and a Russian crewmate whose name escapes me flew a couple of years ago. They flew for 326 days. So that's the longest for one person. Astronaut, in terms of the most time in space, the person that holds the American record for that is astronaut Peggy Whitson. And she flew to the space station 3 times, 3 long duration missions. She was the first female commander of the space station. She was actually commander twice. And she has a total of something like 700 plus days in space over her lifetime, and it's the most of any US astronaut.
Wow, that's a pretty long time, actually.
Yeah. Yeah.
And did I hear correctly that someone actually ran a marathon up on the station?
Yes. Astronaut Sunny Williams had qualified for the Boston Marathon right before she launched. And the marathon was going to happen while she was in space. And so she wanted to run it, and she ran 26.2 miles on the Russian treadmill at the time.
Wow. That's pretty impressive, I think, actually.
I'm not a long distance runner, so it's impressive to me regardless, but especially traveling at 17,500 miles an hour on the space station.
Yeah. Another question that came to mind was, and again, I apologize if you said it, but how quickly does the station go around the Earth? Like, how many times? Is it just once every 24 hours, or?
Great question. So it travels, like I said, at 17,500 miles an hour. That means it goes around the Earth once every 90 minutes. So in the time frame that we have is one day, 24 hours, they actually go around the Earth about 15 times in a 24-hour period.
So is it possible for us to see the station more than once per day?
Typically not, because by the time that the space station gets back to the same place in orbit, Earth has rotated underneath it. So it's going around, but since we're rotating underneath them, we will typically only pass over, or excuse me, we would pass underneath the space station twice a day. But typically one of those is going to be in the daylight, when it's daylight here on the ground, and we can't see it because the sun's too bright.
Very cool. Looks like we do have another question that just came in the chat as well. On Earth, we use time zones. Is the space station using those time zones or something different to determine time?
That's a great question. Again, with the International Space Station, like I mentioned, we've got mission control centers in many different time zones. So we all synchronize to one, and we picked one reference point just to be easy. So we picked the 0 longitude line that goes through Greenwich, England. So we use Greenwich Mean Time, GMT. So basically the astronauts, their time schedule is similar to the folks that live in London. So they're basically on the same time of day as folks that live in London. And then all the rest of us on the ground, regardless of whether we're in mission control here in Houston or in mission control in Russia or Japan, we all shift in the mission control center to that time frame. It's a great question.
Very cool. Another question that comes to mind as well, and again, for anybody that does have a question, feel free to type it into the chat, and we'll make sure that gets answered. But another question that comes to mind is about the training to be on the International Space Station. What more training do they go through, or about how many hours of training do they have to really understand as best as possible what it's like to live on the station before they actually get there?
That's a great question. So astronauts typically start training for their missions on the ground anywhere from 1 to 2 years before they fly. Their assignments happen. We've shortened that over the past several years, but typically it's on the order of a year. And if you can think about, a year ago, did you learn something? Would you remember exactly how you did it? Probably not. They learned a whole lot of information, not only about, for example, some of the things I showed you, how to use the different facilities on the space station, the exercise equipment, how to use the toilet, how to do research on the space station. That's a whole lot of information. So we have special ways that we write procedures to help jog their memory. We try to follow a standard way of writing what to do when they get up there so that they can kind of pull on those nuggets that they'll hopefully remember. And if not, we provide more information. A lot of their training is more on maintenance activities and general how to use different equipment in space. And then when they get up there, we'll tell them, all right, you're going to use that. Remember that tool that you learned how to use? We want you to use it in this manner for this research experiment or in this maintenance activity. So we try to train skills, and then they can use those skills when they're needed on the space station.
Very cool. We have another one. So I heard that time in space affects the body in similar ways to aging. Are there any long-term effects?
That's a really good question. One of the main effects if the astronauts didn't work out at all would be reduction in muscle mass and also loss of bone density. Because here on the ground, as we're walking around, the gravity forces our muscles, even if we aren't exercise champions, just walking works our muscles enough to keep them strong. So when you go to space and you don't use those muscles, it can be really hard when you come back to do things just like walking around. So one of the main things that we do to counteract that activity is exercise. That's one of the main reasons that they're exercising on the space station. And also because they're exercising, we're trying to find different ways to exercise so that, again, the farther we go from the Earth, we can improve the ways to exercise for longer missions. But also another thing that's come to light, I think that was unexpected in recent years, is change in eyesight. And that research is really still ongoing. But what they found is that certain astronauts, after a couple of months in space, would realize if they wear glasses, like I do, my glasses aren't working anymore. Basically, the prescription changes. Or astronauts that didn't wear glasses at all, after a while, might need glasses to focus. And it turns out that when you're in space, again, microgravity, the shape of the eyeball can change. And that affects how you focus. And sometimes on the ground, for different astronauts, they'll come home and they might have no problems. Sometimes their vision might be permanently changed. There's a lot of research that's going on in that, and it's still kind of an open question. But those are the ones that come to mind. It's a good one.
Wow. So we do have a couple more that came in. So in the early picture of the crew member in his sleeping bag, he had a huge wrist watch. What kind of things might he be monitoring?
That's a great question. And I will tell you, the short answer is I don't know all of them. But they do part of the research. There have been research into their sleep patterns, also tracking things like heart rate. Some of them might want to track different exercise, but there's all sorts of different things that I admit I'm completely not familiar with that they track, both with things like a watch, but also they do regular blood collections and urine collections. And then researchers on the ground, they'll freeze those on orbit in those freezers. And then researchers on the ground use that for different research, and especially comparing over the years. There's astronauts that participate in research experiments that where researchers take data for years, decades, to compare the different long-term exposure to microgravity. I'll also say our astronauts, even after they retire from NASA, come back to Houston once a year for an annual physical. And there's this broad depth of data from astronauts going all the way back to the Apollo days of ongoing research, how their bodies have been affected by their time in space.
Well, and that's something that's still being researched in those
Yeah.
may have been in space decades ago.
Yes, ongoing.
Very cool. So Lindsay here is asking, how long is the typical rehab after returning from space?
Oh, that's a really good question. It's going to vary astronaut to astronaut, but it's on the order of a couple of weeks, which is not too bad considering some of them are gone for so long. But again, that has a lot to do with that regular exercise. So that's just in terms of walking. Typically, it's a couple of months before astronauts are approved to drive again, just because it's been such a long time. But it's pretty funny that several astronauts have stories about they get home, it's a week later, and they wake up in the morning and maybe they're having their cup of coffee and they'll drop the coffee cup because they're used to, just putting your pen, instead of putting it down on a desk, just letting it float while I go over here on the space station, do something else, and I come back and it's still there. And it takes a little bit of, so it's muscle memory, right? That you just let something go, it's going to stay there. So that can take a couple of weeks. It's actually not as long, I think, as it used to be because of that exercise.
Nice. So Joel at Heatherwood, which is in Eau Claire, Wisconsin, is asking, what happens with the waste materials?
That is an excellent question. And actually, thank you for asking that, because I forgot to share one of the fun facts. So solid waste is collected in that canister that was underneath the toilet, kind of like your toilet at home, except it's just all collected there together. When that canister gets full, we basically put it in a trash bag, and then we put it in a trash vehicle that burns up in the Earth's atmosphere. So it's essentially disposed of. Urine, on the other hand, is a different matter. Water is really heavy to launch, and it's expensive to launch things into space. And obviously, we all need our water to survive. So one of the things that Space Station has done a lot of research with and really perfected is the concept of reclaiming recycled water. So all of the urine and also liquid that is in the air. So when you sweat on the space station, the sweat, all the water vapor gets collected and sent into a special machine that recycles the water, purifies the water, and it's something like 98% pure. And that becomes the drinking water. So it's recycled water. And astronaut Don Pettit used to like to say, yesterday's coffee becomes tomorrow's coffee too. So we recycle as much as we can in many different ways, not just with the waste, but that's from the human waste side, that's where it goes. For trash, again, we collect all the trash, we reuse things as much as we can, and then we pack it all together. And when we have these different cargo ships come up that bring supplies, we'll pull all the supplies out, and then the astronauts will pack all the trash in and dispose of it. It's a great question.
So is it fair to sort of liken it to like camping, where you have to pack it all in and pack it all out?
Absolutely. It's a great analogy. Okay. And we have to, it's also like camping, if you go for several weeks, you aren't going to be able to do laundry, right? So astronauts have a way of making their clothes last. They'll wear clothes for a couple of days, then those clothes become next week's workout clothes, and then they get thrown away too, and we launch more.
Wow. So we have another question. And so all this waste just burns up in the Earth's atmosphere.
Yeah. So when we bring our astronauts home, it's a pretty complicated physics problem to make sure that we bring them through the Earth's atmosphere that protects us on the Earth from radiation and keeps our air inside. We have to bring them in at a certain angle. If we bring them in too steep or too shallow, either the capsule would burn up or bounce off the Earth's atmosphere. So we bring our astronauts home at a safe angle, obviously, where the capsule will land on the ground. But for our other capsules that have cargo and supplies, we bring them in a different atmosphere where they come in and because of the friction that they go through with the Earth's atmosphere, they'll burn up. So that's how we get rid of our trash.
That's all pretty fascinating, actually. So we've got a few more minutes, and we have another question, which is great. Everybody's really curious about this part of the program, which I think is great because it's an exciting part. But how did they take a shower or a bath?
Yes, it's a really good question. So there's no shower or bathtub on the space station. They basically, again, back to camping analogy, they basically take sponge baths. So they'll have a wash rag and can take water, put a little soap and get suds and wash. For their hair, they use either dry shampoo or no rinse shampoo, and make it as best they can. I've always been amazed with women that keep their hair long in space, because it's got to be a different beast. A lot of the male astronauts will cut their hair short, and makes it a little bit easier to take care of the hair. But yeah, they basically take sponge baths.
Wow. Okay, well, I don't have any more questions at this point in time from in the chat, although unless anybody wants to get one last one in. Ansley, is there any other fun facts that you feel like would be good to know, or just things that might be exciting coming up with the program?
Absolutely. So again, we're excited that we've got our new SpaceX Crew Dragon taking our astronauts to and from the space station. So there'll be another crew mission launching next spring. The date, I don't remember the date offhand, but that's always exciting when we get to launch astronauts into space and then see our astronauts come home safely. I would also say that I always like to leave folks again with words for your family. If you know any person that's 20 years old or younger, they've never lived on planet Earth when the entire human population has actually physically been on Earth, because we've always had at least 2 people living in space. And I think for all the fun science and technology things that we get to do with the space station and research, to me, the thing that I'm the most excited to be a part of is this really amazing international engineering endeavor that has hundreds of thousands of people literally around the world have been a part of, and it's a completely peaceful international endeavor. And it's all I enjoy being a part of that and sharing that with others.
Well, thank you from all of us at Compass and beyond. I want to say personally, thank you so much for joining us today and enlightening us and sharing us. You're a part of the world, or universe, as we probably should say. So Ansley, thank you so much for being here. And before everybody goes, we've got a lot of thank yous coming in the chat as well. Thank you everybody for joining us. But before we go, I also want to put in a plug that we've got a couple more presentations scheduled. And so we hope you will all join us January 12th at the same time, 1 p.m. Pacific time. Tara Joachim, I'm not exactly 100% sure. We'll get the pronunciation right before January 12th. She's going to be talking about extravehicular activities on the International Space Station, which I believe is walking out in space. Yep, I'm getting the nod from Ansley. That's what that is. And also on January 26th at the same time as well, Brian Johnson is going to be talking about the next generation of extravehicular activities and their new spacesuits. So all related to the ISS, which should be very fun. And we did have a little bit of trouble with our Facebook live stream at the beginning, but we will be posting the recording as well. So if you missed the beginning, sorry about that. And we'll post the recording so that you can watch it here after the fact. But for all of you that joined us, thank you so much for joining us. And we hope to see you again on January 12th. And happy holidays, everyone. Thanks, Ansley.
Thank you.